Okay, so question number 9 is look at the molecular orbital for O2. What is the bond order? And to increase the bond order of O2, should you add or remove electrons? And what is the charge and the bond order of the new species made in part B? So they included the molecular orbital diagram for oxygen, but let me kind of label it a little more. So I'll draw in all of the different orbitals here. And this is a good molecular orbital diagram, but it's kind of just missing some of the labels. I'm just going to quickly sketch it out. And this orbital here is the 2s orbital. And these are the sigma. (2s), and at the top is the sigma star 2s. So this sigma star refers to the anti-bonding orbitals of 2s. So now at the top here, we have our 2p orbitals. And we have the sigma 2p. And at the top here, we have our pi orbitals. So pi 2p. I'll just write it once so that it's not too crowded. And on top of that is the pi star 2p. And then at the very top is our sigma star 2p. Okay, so on the left and the right is a regular molecular orbital diagram for a single oxygen atom. So they have the 6 valence electrons drawn in. 1, 2, 3, 4, 5, 6. And since this is O2, we have 2 oxygen atoms coming together. So they're going to have the same molecular orbital diagram. And in the middle, we can show how they kind of bond together. So these 4 electrons can fit in here. And now we have the remaining 8 electrons to fit in the middle right here. So 1, 2, 3, 4, 5, 6, 7, 8. So let me write the bond order equation on the right. So bond order is equal to the number of bonding electrons minus the number of anti-bonding electrons oh, it's cut out, sorry. So bonding electrons minus anti-bonding electrons divided by 2. So if we calculate the bond order of a neutral diatomic oxygen, all of our bonding electrons are in just the sigma or the pi orbitals, so we just count that out. So 1, 2, 3, 4, 5, 6. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bonding electrons minus 2. And 1, 2, 3, 4. So we have 4 anti-bonding electrons. So 8 minus 4 divided by 2 gives us a bond order of 2. And the second part of the question asks, to increase the bond order of O2, should you add or remove electrons? Okay, so let's look at our molecular orbital diagram. So to increase the bond order, the removal of electrons might be better since the orbitals for the bonding electrons are already filled. I'm just going to write that down. So for example, if we removed the anti-bonding electrons at the top, so let's say we had the bond order of O2 2-, then we would still have 8 bonding electrons, but this time we would have 0 anti-bonding electrons divided by 2, so then this would increase our bond order to 4. So for part B, removing electrons and increase the bond order. Okay, so now for part C, what is the charge and the bond order of the new species made in part B? Okay, so I calculated it already, and it would be 4. Oh, sorry, when you remove electrons, it has a +2 charge, so let me just change that. Okay, so this is D, B, and C in 1, so let me just write that here. And you get the bond order of 4. Okay, so let's see what the junior tutor said. So we kind of did the molecular orbital diagram together. They have the equation for bond order, but I think they counted out only 6 bonding electrons. One, 2, 3, 4, 5, 6, 7, 8. So I'm just going to fix that. And the anti-bonding electrons should be the ones that are sigma star or pi star. Okay, so this explanation is correct. However, the bonding electrons are located in the sigma and pi orbitals, whereas the anti-bonding electrons are in the sigma star and pi star orbital.